Okay, g'day folks, welcome back to KIERAN'S training. So recently there's been some changes to the calculations assessments for dogging. Okay, so now they're primarily focused on being able to read a sling chart as opposed to using the various formulas for working them out. Okay, so we're going to take a look at some sling charts and look at exactly how we're going to use them to determine what capacity slings are going to be required to do the job. Okay, so we'll take a look at this scenario to start with, so I'll just minimise this window a little bit and we'll have a look at what we've got underneath it. Alright, so just 1 minute, there we go. No, didn't work. Alright, here we go. So, in this scenario we've got a spreader bar lifting a load weighing 6.8 tonne. Okay, we've got two flexible steel wire ropes underneath the spreader bar, and we've got some 100 grade chain above the spreader bar at a 60-degree angle. Okay, so the first one we'll take a look at is we'll take a look at the flexible steel wire rope. Okay, now the thing with the spreader bar is if you've got an evenly balanced load underneath it, each side is going to be taking half of the weight. Okay, so if we're lifting a 6.8 tonne, that means each of these flexible steel wire ropes need to be capable of lifting 3.4 tonne. Okay, so to look at the sling chart to do that, alright, I'll just drag that sling chart across here. So we'll bring this across. Okay, so if we look here, it's direct loaded because it's not choked around the load. So if we have a look there, just a direct load at the top. Okay, so two slings directly loaded, and we just run our way down this column until we can lift the 3.4 tonne. Right, so at 16 mil we're good for 3.1, not quite there yet. So we go down to the next one, so 18 mil here means we can lift our 4 tonne load. Okay, so in this instance we need a minimum of 18 millimeter flexible steel wire rope underneath that spreader bar. Okay, so that is the lower slings. So now we'll take a look at the top slings. Okay, so 100 grade chain, 60-degree angle. Okay, so when we're looking at the weight of the load, those slings are taking the whole weight. Okay, so in this instance we've got the 6.8 tonne load plus we have a 200 kilo spreader bar. So in total we have 7 tonne of weight on those chains. So to determine what chain slings we need, alright, we'll look at the sling chart for the 100 grade chain. Okay, so when we take a look at this chart here, alright, it gives us a few different variations. Okay, so this instance it's directly attached because it's on the spreader bar, alright, and we've got a 60-degree angle. Okay, so with the direct attachment you'll notice we've got a 60-degree, 90-degree or 120-degree. So 120-degree being the maximum allowable angle between two legs of a sling. Okay, now over here where you've got reeved slings, you'll notice it only has 60 degrees because if you have your slings choked around the load, 60 degrees is the maximum allowable load. Okay, so we're over here, we've got a straight attachment at 60 degrees. So we've got to have a look and we just run down this column here, straight slings at 60 degrees, and we run down until we can lift 7 tonne. Right, so we can see the 10 mil can lift 6.9, so we're not quite there yet. So we go down to the next one, and our 13 mil 100 grade chain can lift 11.6 tonne. Okay, so the slings required to lift that load on top is going to be 13 millimeter. Okay, so it's nice and straightforward, that one. So we'll move this back over here out of the way. Okay, so now we'll take a look at some softies or synthetic slings. Okay, so we'll roll down to this next scenario. Okay, so we've got a pair of softies, okay, lifting up a bunch of loose steel. Alright, so first thing we want to do is we want to work out how much the weight of that load is before we can decide what slings we need. Alright, pretty critical to know the weight of the load. Alright, so let's say for example in here, let's say pipe is, let's say, 20 kilos per metre. Kilos per metre. Alright. After that, we will say that they are 5 metres, let's say 5 metres long. So 5 metres long. Okay, and let's say we've got 20 of them in there. Alright, so 20 pipe. Alright, so first thing we need to do is work out how heavy the load is before we can decide what size slings we need. Alright, so to do that, alright, if the pipe's 20 kilos per metre, you go 20 times, they're 5 metres long, times 5, and there is 20 of them. Alright, so we do that. So when you're working out the weight of the load, just multiply all the three numbers out by themselves. Right, so 20 times 5 would be 100. Right, 20 times 100 is going to be 2,000. Okay, so that equals 2,000 kilograms. All right, don't forget to put your unit of measurement on there. Okay, so if we've got a pair of softies, and because it's choked, we know we're going to have a 60-degree angle. All right, because we can't have any more than that. Alright, so what we'll do, we've got to lift a 2-ton load and it's going to be choked, and that's 60 degrees. Alright, so we'll bring across our sling chart for the softies. Alright, so you've got all your different variations along here. So in this instance, okay, we've got 60 degrees and choked. Alright, so we're looking right here. Alright, so what size slings do we need? Alright, so the 1-tonners can't quite do it. Right, so if we go to the 2-ton, or your 2 right here, we can lift 2.7 tonne. So slide back across, right, and that tells us they are 2-ton slings. All right, so in order to lift this load, we're going to need to have a pair of 2-ton slings as well. Okay, now just take a look at this little diagram. Right, you'll notice they've only got a single wrap on it. All right. Just remember, if you are going to be slinging any loose items, always make sure you double wrap those slings as well, alright, just to prevent the slings from slipping. Okay, so if they're not double wrapped, you will find those slings will actually slide in on you. The load can become unbalanced and start falling out, which is never a good thing. Okay, so there's your softies. Alright, let's have a look at some chains. Alright, let's just close that one off. Alright, so let's see if I can find the right picture. Here we go. Alright. So, when we're looking at a chain sling tag, alright, so if we've got this arrangement, right, let's say we have 90 degrees between the legs here on the diagonal. Right, so you always look for the greatest angle between any of your legs, and that's going to determine what angle you're going to use when determining the capacity of the chains. I will just find the, here we go. So, well, I'll just put that to the side. Alright, so if we had 8mm chains, alright, directly attached here, alright, and a 90-degree angle across it, right, then we're going to be looking at our sling tag to find out how much we can lift with those chains. Right, so in this instance, you'll notice on a sling tag you'll have the grade of chain, so in this instance it's 80 grade. It's going to have the diameter of the chain, it's going to give you your different angle factors, alright, and your choking factor if it's rigged around the load as well. Okay, as with all lifting equipment, it's going to have a serial number or some form of ID on it, so you can put that into the lifting register and identify it. Okay, so 90 degrees, directly attached, means these chains can lift 2.8 tonne. Alright, okay, if it was choked, once again, you can lift no more than 2.6 tonne, because being choked, 60 degrees is the greatest angle that you are allowed to use. Alright, so that was just a quick look at the flexible steel wire rope, the synthetic and the chain charts. Alright, I just want to have a quick look at if you're lifting something with different length slings or chains, alright, because to decide what angle you're going to be using. Alright, so where's this other diagram I had? Here we go. Alright, so if we've got something like this, alright, so we've got to see if I can make that a little bit bigger for us. Alright, so got an asymmetrical load, alright, so when we look at our slings at the top, we're not going to end up with the same angle, alright, so if we were to, from the center line, if that was a 30-degree angle from here to here, alright, then you'd use a 60-degree angle, or because it is, let's say it's 45 degrees to this one. Okay, so if you've got two angles there from the center, one's at 30, one's at 45, you're always going to use the bigger one because that's your weakest point. Right, so if that's a 45-degree angle there, then if you had two of them, it'd be 90 degrees, and 90 degrees is the angle you're going to use to work out how much you can lift in that situation. Alright, so let's say this load weighed 7 ton. Alright, let's bring our chain chart across again and we'll have a look at that. Where are we? Okay, I've got the synthetics. Alright, there we go. Okay, so once again it's a direct attachment. Alright, we said it was 7 ton. Alright, so direct attachment, 7 ton. Now we're using 90 because that is the bigger angle, alright? So remember, if we had 45 here and 30 here, we'd go for the bigger angle, alright? So 245 is going to end up giving you a 90-degree angle, so we're going to look at 90 degrees. Alright, so if it's 7 ton, we run down our chart here, alright, and here we go. We've got the 13mm chains that we can lift 7 ton at 90 degrees. Okay, so that was just a quick wrap up on how to select the slings you're going to use. Okay, now once your slings have been selected, obviously you're going to need to inspect your slings. So I've recently done another video on inspection of slings if you want to go and check that one out as well. Okay, now keep in mind you still need to be able to work out the weight of a load, right? And one that you're still going to have to remember in order for the dogging assessment is to work out the weight of a pipe. Okay, now if you want to jump back over to my other video on dogging calculations, you'll be able to find that formula in there as well. Alright, quite a simple one, pi r squared times length, alright, inside diameter, outside diameter to work out the weight of the pipe. Okay, so thanks for listening. Okay, and don't forget to like and subscribe to keep updated on any new things that are happening. Okay, thank you, bye.